In the previous video, we discussed how to find out the hybridization of carbon atom in any compound, but in the video the sound quality was not that clear, so I am repeating again. Remember, if in any compound the carbon atom has 4 sigma bonds, that will be your sp3 hybridized. Like for example, if we take methane, we can see that this carbon content all are single bond. That means all are sigma bond. Remember, where all the bond are single bond, that is sigma bond. That means there is 4 sigma over here, 4 sigma, 1 2 3 and 4. That means this is an sp3 hybridized carbon atom. This carbon atom is a sp3 hybridized. But in any compound, if carbon contains 3 sigma and 1 pi, that will be your sp2 hybridized carbon atom. Like for example, if we take CH2 double bond CH2, we can see that here each of the carbon atom contain 3 sigma and 1 pi. How? Now see, if we break this molecule, C double bond C, H and H, you can see that this carbon atom contain one single bond, that is sigma, then pi, this is single, this is sigma, and this is sigma. That means 1 2 3 sigma plus 1 pi. That means your this carbon atom is your sp2 hybridized. In the same way, if we take this here, remember 2 sigma 2 pi means your sp hybridized. Now see example, CH triple bond CH. In this triple bond, remember always in the triple bond, one is your sigma and another to your pi. So for this carbon, if we break the structure, we can see H bond C, C bond H. That means this is sigma and this is also another sigma. That is 2 sigma we have already obtained, and this is your pi and this is another pi. That means 2 sigma plus 2 pi. This is your sp hybridization. Sorry. Now see, let's take some example. If we take this example and break this molecule, C bond C double bond C, one is your hydrogen, another is your hydrogen, this is another hydrogen, hydrogen and hydrogen. Now start from this carbon, here you can see 1 sigma 2 sigma 3 sigma 4 sigma. That means 4 sigma, this will be your sp3. That means this carbon is your sp3 hybridized. For this carbon, if we take 1 sigma over here, second sigma over here, and 1 pi, and third sigma here. That means this carbon contains sigma and 1 pi. That is your 3 sigma plus 1 pi. Then it will be your, according to this, sp2 hybridized. This is your sp2, and for this carbon also we can see that 1 sigma 2 sigma and 3 sigma and another pi. That means 3 sigma plus pi. This will be also your sp2 hybridization. Now see, for benzene, most of the students get confused whenever we talk about the hybridization of benzene. Now if we draw the structure of benzene in simple carbon atom form, we can see that here it is a double bond, and here, and third is here. One hydrogen. Each carbon of benzene contain hydrogen atom, and all you can see all are similar. So if we take this carbon, 1 sigma, second sigma, third sigma, and fourth is your pi. That means 3 sigma plus pi. This will be your sp2. In the same way, each of the carbon will see the same configuration or the same structure. For this carbon, sigma and pi. That means all the carbon atom of benzene is your sp2 hybridized carbon atom. And now if we take this carbon, you can see that this carbon have 4 sigma bond, but this carbon also 4 sigma, this carbon also 4 sigma, and this carbon also 4 sigma. That means all the carbon atom over here are sp3 hybridized. If we break the structure, we can see it more clearly. You can see each of the carbon atom contain 4 sigma bonds, sigma, 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 sigma. For this carbon also, this is a sigma. In this way, all these carbon atom are all atom are sp3 hybridized. Now, there is a great confusion whenever I talk about carbocation and your carbanion. For carbocation, if we take this carbon CH3, bond C, bond H, and another H, this is your positive charge, that means carbocation. Here you can see 3 sigma bonds, 1 sigma, second sigma, third sigma, that means carbocation is your sp2 hybridized. And in for carb anion, we will take the carbon which contain the negative charge, hydrogen, hydrogen, and here is your negative charge. Remember, here you have to take all the sigma bond. With that, we will take this lone pair electron also as your sigma bond. Actually, if we see the structure of carb anion, it will look like in this manner. C H H C3, and one is your lone pair electron over here with negative charge. That means we take as a sp3 hybridized. Remember, if you forget the hybridization of carbon ion, just compare the carbon ion with your ammonia. You can see with your ammonia, NH, H, and one lone pair. It is your sp3 hybridized. In the same way, one carbon ion is also sp3 hybridized. That's all.